If you do chemistry and you're stuck with trying to understand the trends in the periodic table, if you know just these two things, you can explain pretty much all of the trends that you see in the periodic table. First thing is that the positive protons that are found in the nucleus attract the negatively charged electrons that are surrounding it. It makes sense. Opposites attract. The second piece of information you need to understand is that electrons don't really like each other. They're both negatively charged, so when they get close, they start to repel each other. Let's use that to explain, say, atomic radius. Now you've got two elements here and they both have the same number of electron shells, 1, 2, 3, 1, 2, 3, which means they're found in the same period. But why is it that sodium has a much larger atomic radius than something like chlorine? If you have a look at it, 11 protons for sodium, 17 protons for chlorine. That means there's a stronger positive pull in chlorine thanks to having more protons than sodium. What allows the nucleus of chlorine to pull those electrons closer to itself. It's like it has bigger muscles. As a result, by pulling that closer to itself, you've got a smaller radius. Okay, so as you go from left to right on the periodic table of the same period, you can see that the atomic radius decreases. And since both of these have 3 electron shells, you're still having the same repulsion in these inner 2 shells, right? So that hasn't really changed, but you've increased the positive pull towards the nucleus. Okay, let's use the same thing to explain first ionization energy. That just means how much energy is required to pluck out an electron from an atom to make it an ion. The further it is from the protons, the easier it is to happen. Why? Because the proton's ability to pull it towards the nucleus is pretty weak if the electron is really, really far away. Not to mention, remember, you're still fighting the repulsion forces from the inner shells here as well. So what I'm trying to say is the further it is from the nucleus, the harder it is for the protons to hang on to that electron, the easier it is to lose that electron, which means there's a lower ionization energy. So can you see how the same concept explained both of these periodic trends? You could apply the same thing to electronegativity as well. By the way, my name's Catherine. I'm a former high school VC chemistry teacher and textbook author, and now all I want to do is to teach you everything I know. Remember, no matter what anybody says, yeah, you can.